Hello everyone, welcome to the first part of this machine learning with Python, and we are going to understand about the machine learning in this part. In this part, we are going to cover the very basic, the very fundamental of machine learning. We are going to get to know that why we should learn this machine learning right now, and we will also understand its core terminology, which should be known to everyone if we want to implement the machine learning to our project. So let's start. When it comes to the machine learning, we must know the approach of human learning because this is what we are going to implement in our machine learning. So, what's the general approach of human learning? Let's take an example of a child. All the data, all the knowledge which comes to a child into his starting phase came from the parent. And what kind of data? That even the child wanted to know, or child was just looking at some particular object, the parent was there who was repeatedly telling to its child that, hey kid, this is a table. Hey kid, this is an apple. Please say apple. While calling that apple, the parent was also showing that apple to the child. So in this way, a child learned in his initial state. So the same thing goes with the machines. When we come to this machine learning, that computer is just like a child. As a parent, when we were feeding data to our children, the same way we are going to feed data to our system. But we are not going to set rules to the system that you must do this with that data. We will ask the system to find the pattern between the data. The system will find the pattern between the data by itself, and then it will provide some output to it. See, as a child, as a human, when we teach something to a human, they understand the data, that they store that particular information to his brain, and with by storing that data into his brain, the human try to create relationship between all that data which he gathered for a particular subject or for a particular object. So in this way, while creating a relation between that data, the human got to know that, okay, now I understand this concept, that now I understand what that object is. The same thing goes with these systems, the computer system. When we feed data to that computer system will try to create some relation between that data, and after creating that relation, it will give the output. And then it comes to us that we validate that output. If that output is correct, then we will provide the positive feedback to it, and then the system will understand, okay, whatever I'm doing, whatever the relation I'm creating is correct. It's the same way when we teach something to a human or to a child, then child will provide some answer and ask us to validate. When we validate that, okay, you were able to identify that this is an apple, or you were able to solve this equation, then that particular child or that particular human got to know that, okay, whatever that he learned till now was correct, and he is able to use that knowledge to go further. The same thing goes with the system, the computer system. When the data which we have provided went into the computer system did some kind of process for that data, some relation to that data, created some output from that data, and from that output, when we validated that yes, this output is correct, then system got to know, okay, this relation is correct, this pattern is correct, what I've created. So now the next time when I enter the data, again it will try to create the same pattern, or it will try to add that data into the existing pattern or into the existing relationship, like our mind. We are not going to create a conventional program like we do till now, like creating a sum of two numbers in which we are going to set some rules, in which we are using this a plus b, then return the a plus b. We are not going to do that. We are just going to provide data and data to the computer system, and the computer system will got to and the computer system should find a way to relate with that data by itself and provide the output. We can channel the output, that what output we want, but we cannot create the instruction for the computer system that how you are going to do it. So this is what machine learning is. Machine learning is like creating a simple human brain inside a computer system, providing lots of data to it, because with that data only it can gain the knowledge, it can gain the relation, and when it gain the relation between the data, then only it can provide the output. So this is the basic concept of machine learning. Coming to the flow, that how this flow work in machine learning. So we have this data which I told you about till now, and when we developing a machine learning model, that what model is? Model is your computer system, that I'm providing input to your computer system, which is called as model, and that model is providing me an output. So when in a starting phase, when we are creating a model, what we are doing is we have some set of algorithms and we are feeding data to that algorithms. Those algorithms by themselves try to create relation with that data, and after creating relation with that data, those algorithms will provide us the output. So in a phase of developing the model, the models are nothing, just the algorithms. And when we are satisfied with the output of these algorithms result, then we say that okay, my model is completed. Then we shift our terminology from algorithm to model. When we are developing, these models are nothing but the algorithm. When we are completed, again, these models are nothing but the algorithm, but they are like able to do the task which we wanted it to do. So models are nothing but just the algorithms. Okay, why we should learn this machine learning? And nowadays there are multiple examples in which we are using the machine learning right now. We have software of recommendation. When you go to the Netflix, when you go to the Amazon, based on your search history or based on your watch history, they have some machine learning models. Those model will detect some more content related to that particular genre on which you are watching the content, and they will recommend it to you so that you can continue watch whatever the content they are showing, so they can keep you engaged with their platform. See how they use this machine learning with only the search history or only with the watch history you are doing in that platform. Spam detection in your Gmail, in your Outlook, you see there is a one junk folder, because these companies trained these junk sections so good. That's why all the mails which have some kind of spams, some kind of viruses, they directly go into the junk. They directly go into the spam. And then from there, you don't have to open it, you have to just delete it. Speech recognition, fraud detection. There are multiple apps which can detect the fraud number just at the live calling. So how they did it? Because they were trained with lots of data. After training with lots of data, we provided the feedback, okay, that you are doing right, you are doing wrong. And in this way, the machine learned in such a good way that now they are able to do a very complex task in a real time. See, this is why this machine learning is so much required to learn, because we are entering into the age of those applications which are which are giving us data in so much bulk, and we need to filter it in a way that we can provide the best service, or we can provide the best output to the customer, so that customer will be with us for the rest of his life. Supporting those examples, there are other factors too, which are booming this machine learning nowadays. What are those? This data deluge. What is this data deluge? Currently, there are lots of data centers right now. They were not there in the past, but right now, these data centers are opening every day. And if I see the applications like Instagram, TikTok, Facebook, Google, there are billions of people who are using these applications per day. And when I'm saying about the billions of users, then it means they are creating tremendous data every day. And now we are capable to store that data. After storing that data, we have like much more increased RAM right now, which we didn't have earlier. So because of lots of data, because of large amount of RAM to process that data, we are able to provide an algorithm so that the RAM can be used, and that RAM can be used to process that petabytes of data every day using these machine learning. And with these machine learning and with these equipments, now all the applications are equipped with the machine learning so that they can provide the best experience to the users. This is the representation of algorithmic advancement. This algorithmic advancement is also a one support to this machine learning. As we have lots of data, as we have lots of RAM, we have lots of training data. Because of that only, we were able to create the algorithms which are so much advanced that they can provide you result in a real time. See, these all things are interconnected. First, we understood that most of the application are using these machine learning, and why they are able to use this machine learning, because data centers are there, because lots of RAM is available to the users right now, to companies right now. There are supercomputers. Nvidia is working on some very large scale supercomputers. So when we have lots of data, when we have lots of RAM, when we already have the algorithms, it means we can train our algorithm till that extent so that they will become very advanced. And because of these advanced algorithms, everything processing in so much faster way that user is not able to realize that his data is getting processed every second. And not only for a single user, or for all the billions of users, the data is getting processed every second. And these algorithms are become the backbone of these machine learnings. So we understood these two things in a shell. So now let's understand its core terminology part. So this core terminology consists multiple subparts, that is dataset, features, target variable, model, training, inference, supervised learning, unsupervised learning, and reinforcement learning. We are going to get a glimpse of all these things in just a while. So coming to this dataset, what is this dataset? As I told you, like we are using the data to train our computer. That data is nothing just a data set. So here we can see this data set have three parts: this feature 1, feature 2, feature 3. These features are nothing, just the part where you can say this feature 1, let's for an example, it is the model of a car. Let's say we are creating one machine learning model in which we are going to predict the price of a used car. So as a feature 1, it is a model. As a feature 2, it is the average which that particular car is providing. And the feature 3, it is the price at which those cars were sold. So we got this feature 1, feature 2, feature 3. It can have multiple values, like this model 1. It can be BMW 1, and it can be BMW 3, 2, anything. As it's a model, it can be Audi, it can be Honda, it can be anything. And based upon its average, we have the price. So here we have this data set which we are going to give it to the model. Now let's coming to the next slide. Okay, again this features, as I told you, like this feature 1, feature 2, feature 3, like this particular column 1, column 2, column 3, they all are its feature which we just got to know earlier in a data set. Coming to this target variable, the one you are able to see in a purple light. So what it is like from our model, what we are going to do is we are going to, or we are trying to predict the price. So once we have this complete data, we are going to provide these all rows to our model, and after certain of point we are going to provide only these two things. After providing these two things, we are going to expect from our model that it will provide us the feature 3, like price. So what we are expecting from our model is price. So inside the machine learning, we have this 3 thing when it comes to the data which we are going to provide to the model. That is one, the data set. The data set contains the complete data, whatever you have. Second comes the feature. We have divided our data into the feature. Data can be random, data can be text. So what we did, we moved that data into the feature. In a feature, we segregated that. Like the one column was of model, the second column was of the average of that car, and the third column was of the price. And coming to the target variable, the target variable was the one which valued the most, like the price. If those earlier car were sold at this price, and if I'm going to provide this data like for too many cars, then after certain of point my model will understand, okay, if this is the car model and if this is the average it is providing, then it should cost at this price. So we understood the terminology of this training data, this feature, and this target variable. Now let's come to the another slide, which is terminology of model. As we discussed till now, we are just revolving around the model. As I said, models are nothing. It's the algorithm. It's the algorithm which was trained with the data. Once when the algorithm was trained and it is providing the expected result, then after that we are calling it as model. So we are providing input data to the algorithm, that algorithm is processing it, and when it started to provide the expected output, we are calling it as model, and we are expecting its output as our result. So it's the model. Coming to the training, again, when we are providing the data to the algorithm, that is called the training. We are providing that data to the algorithm till that point when the algorithm is providing the correct set of output. But also we need to take care that when we are providing the data, that the data should be relevant. So that's also a key point when you are training an algorithm or you are creating a model. Inference. Inference means prediction. So as I said, we are expecting one output. So if I have the new data, see, I have one set of data in which I have trained my model, in which I have trained my algorithm. After training that algorithm, a model is created. Now it is expected from that model to create the output from the new data. And when we are going to provide the new data to the model, it is going to predict. See, that is called the inference. And now coming to the supervised learning. So till now we have used this example when we have this data in which we have the name of the car brand, we have the average of a car, and we have the expected output. So what this supervised learning is, I am providing you all the data and also I am providing you the output. all I want you to do is to create a relation between the input and output. This is the methodology which is called as supervised learning. So in a supervised learning, I am providing you the input. In supervised learning, I will provide you the output. All you have to do is to create a relation between the input and output. So it is called the labeled input and labeled output. See, it's very simple. Coming to the unsupervised learning. What is unsupervised learning is I'm not going to provide you any output. All I'm going to give you is data and nothing else. When I'm giving you that data, all you have to do is to find the pattern. Let's take an example. If I'm going to provide my search history of YouTube to particular model, let's say I have two friends, me and my two friends are there. All we are going to do is we are going to provide our YouTube history to this model. For this model, we all are different person. But from the search history, it find out, okay, this person A is liking this particular kind of video, this person B is liking the science video, and this person 3 is liking the entertainment video. Again, it needs bit of more data. So what I did is I provided my profession. As say I'm an engineer, my friend is a scientist, and my other friend is a cricketer. So after providing that, it labeled by itself that if a person is engineer and its browse history is like this, so whenever a new customer comes into the picture and if his profession is engineer, I'm going to provide the similar result to that person D2. So see, I didn't provide any kind of output. I just provided the data to the model, and it's the complete work of model only to analyze all the thing by itself. So this is called the unsupervised learning. Coming to the reinforcement learning. So what reinforcement learning is? See, from the diagram, we can understand like there are four parts: agent, feedback, action, and environment. So how it all works? What we do is we provide an action to the agent in an environment, and when it do the task or it do the it provide the output, we provide the feedback. If the feedback is positive, we reward it, and if the feedback is negative, we punish it. So in this way, the algorithm will understand, okay, if this particular set of input, I am providing this output, I'm getting praised, and if for this particular, and for the same input, if I'm providing that output, I'm getting punished. So it stored that all this cycle of the feedback cycle, and it trained itself. So after getting all these feedback, all those punishment, it create a record in itself, and it create a relation in a way so that it provide the output which only got the positive feedback. So let me give you an example. For a supervised learning, okay, this is, for an example, this is often used in a navigation system. So coming to the navigation system, whenever it provide us the route and we were going into it, after reaching to the destination, it asks us that whether I am right or whether I was right or wrong. If you have provided yes, okay, right, then it stored that data that okay, whatever the output I have created, it was correct. And if I do this negative sign, the negative feedback, then again it will try to get the negative feedback from others too. When it reaches to the threshold of those negative feedbacks, then it will reroute it from the other sources. So this is the example of the reinforcement learning. Reinforcement learning is what? This is a type of machine learning where an agent learn to make the sequence of decisions in an environment to maximize the cumulative reward. Means the agent learns through the trial and error, and receiving feedback in the form of rewards and penalty. So if the feedback is positive, it is going to collect the reward, and when it is collecting the reward, it means it is accumulating the reward. So this is the reinforcement learning. So we have covered all the core terminologies used in the machine learning. We understood what machine learning is, we understood what model is, we understood what algorithm, why we are using machine learning, where we are using machine learning, and the key terms which are used inside the machine learning. In the next part, we are going to cover this supervised learning, unsupervised learning, and reinforcement learning in very detailed way. So stay with me, and if you like this video or if you have any doubt, please comment and do the subscribe, and please click the subscribe button if you like the video, and let me know if there is any issue you found in complete video, or if you got any doubt. I will be there, I will help you. So thank you.